All right. So here we go. Starting a little late, but this is what we got. If you would please open this map, and what is the first thing you want to do when you get this map open? What do you see right off the bat that we need to do? Repair our data sources. The files are in the projections assignments. And if you link one, the rest should jump on the map. Now, the handout I sent around, which is also on Teams for you, Chris, the handout I sent around has what this map is supposed to look like. And what I want to do today is go through these files one by one and figure out whether we project or define project on the files. If I tell you that the only file on here that's correct is Richland County, you need to pick the rest of the files and either project or define and project on those files. And as you can see, the data frame is a bit work. So, what's your first step? Very first thing we want to do, if Richland County is the only file that's correct, it's in the correct coordinate system, it's in the coordinate system we want to be working in. Check its coordinate system. What coordinate system is Richland County in? Anybody? UTM zone 13 north. The reason this is 13 north instead of 12 north is because Richland County is in far eastern Montana. So if you look at that handout I gave you about the UTM zones, this county falls in far eastern Montana in the zone that's 13 north instead of 12 north. So what we want to do is put each of our files in UTM zone 13 north. One by one, let's go through it. Ditches. What do we need to do with ditches? Project is define projection. Project. Only two choices. Yeah. Okay, your first clue right off the bat. Ditches is the brown line. Is the brown line on the map or not? Oh no, I see it. Okay. These are your ditches right through here. If you turn everything else off, you can see those are your ditches. That's what we want. And because I told you Richland County is the correct file, the fact that they fall within Richland County is a good indication that they're where they're supposed to be. So why do we project instead of define project? When it's not in the correct location, or when it doesn't have a coordinate system. So look at ditches, look at the coordinate system here. We're in NAD 83 state plane meters. And it's showing up where it's supposed to show up. So like I said last class, it's always good practice to put your files in the same coordinate system so your system isn't doing that on the fly projection and trying to put everything in the view of the data frame. We want to keep everything in the same coordinate system. So let's put this in UTM zone 13 north. There are toolboxes up here, little red box. You probably don't have it on yours. And again, if it's just in the middle of your map, you can pick it up and hover over one of these blue circles to make it sit where you want. Anybody remember where project was? I'm sorry? It's okay. Shout it out.
Under projections and transformations.
Projections and transformations, which is under data management rules. But remember, if you don't know where it is, you have this little search tool over here. You know what it's called. You can look it up. So we want project data management. The reason I don't like the search tool is because you get everything in here. If you don't know which one you're looking for, you can easily go astray, but we're looking for data management tools, projections and transformations, and project. So we'll start with ditches. And what coordinate system do we want to put it in? Yes. Anybody want to take a stab at finding UTMs on 12 North or 13 North since you don't have it favorited? First folder is the most important one. Which is the first folder? Geographic coordinate system or projected coordinate system? Projected. Good. Excellent. Well, that makes me take a stab at the next one.
Yes.
All right. So this one's going to be in North America. Yeah, down at the bottom of North America, it's the.
Is there a difference between the one under there and the one underneath the bad 1983 folder?
Yep, you're right. It is an ad 1983 folder. I'm sorry. And it's 13 North. It moves it around on me. I'm getting mixed up. It is NAD 1983 UTM. 13 North. Okay. You don't need to assign anything else, but make sure this is going where you want it to go and not in your default VO database. And say okay. And well, my ditches are locked right now, but shouldn't work as soon as it's done. Didn't work. Let's see why. Not much. I'm just going to try and run that again because I don't know why that didn't work. Okay, good clue that you did it right. It's where you want it, right? So if this had jumped off the map and gone somewhere else and had changed, you probably used the wrong clue. And in that case, what do? What's that? Yes, no, that's exactly what I want you to do. That's exactly the right answer. Always start over. Don't try and correct it because you're not going to be able to make that mathematical transformation. So start over with the original file. Don't ever try and fix that. You're going to get yourself in trouble. So we're going to remove ditches because we fixed that one. Rivers is next. What do we do with rivers? Define project. Why? It's not there. Zoom the layer and see where it is. Way off in space. Who knows where? So small down here you can't even see it. We know it's supposed to be in Richland County, but your teacher's not that mean. So we want to define the projection on this. And we have two different ways to do it. We have the tool and we have what? What's the other way to define a projection? You guys are killing me today. Seriously, it's right in front of you. How do you do it? Yes, thank you. Properties under the catalog. XY coordinate system tab, and then you can select it there. In this case, it's projecting FIPS 2,500 international feet. We don't want it in state plane, we want it in UTM. 13 North. And because I did it through catalog, it doesn't read that the one I'm looking at on the map is there, so I have to hit refresh. But there it is. UTM 13.1. We know it was defined project because it wasn't in the right place. Township and rain, what do we do? Find project or project? Yes, why? Not where it's supposed to be. So take a look at the coordinate system on township and rain. Here's the other time you define project. This is a pretty good clue that it needs to be defined. It says undefined because it needs to have the projection defined. Okay? You do that one through our catalog. Define projection. And that was township green. All right, watersheds. Define or project. Project, why? In the right place. What coordinate system is it in? Yep. So this is an unprojected coordinate system. This is just a coordinate system, unprojected. So we want to put that in a projected coordinate system, UTM zone 13 north. So we project that. Are you guys, this is actually really important. We're going to have a quiz on Monday. I know you're super excited about that. This is going to be the quiz. So if you're not following this, now is definitely the time to speak up. What's that? No, that's, you're right, I totally forgot. What's that?
It's in the exact same order. So I'm not somehow in while everything else in the world is so it's hard to move forward. Right. I downloaded to them when talking to them, Where?
Are they gonna get communities and I bet I'll answer your question.
I'm anxious.
No, I bet I'll answer your question by you.
You're not allowed to talk.
I'm sorry.
So I just, to the same.
Okay. So it's not in the right place.
It was there before, and then once it was done.
Okay, so it was already in place.
Yeah, so it was right there, but then, since I,
Then you changed the coordinate system it was in.
yes,
So what does that tell you?
I'm just gonna delete it.
Delete it, start over, because you used the wrong one. You used the wrong tool. If it's where it's supposed to be, use project. Because remember, the difference is project is creating a new mathematical coordinate in a new mathematical coordinate system. Define is saying the coordinates are correct, it is in a different system. So when you do that, it thinks it's calculating a new location for it. All right, where were we? Watersheds? So watersheds need to be projected because they're in the right place. Is everybody okay? Yeah, I don't think I did. So give me 1 second. No, you're fine. Let me catch up because I was answering questions and I will finish this. So your township. Township and range is the next one, right? No, the next one is. Okay, you can start it up. Okay. So I'm just gonna go from watersheds to township and range. We'll do the rest as last. Township and range, projected, define, project. I'm gonna start calling on you guys now. I need to know this. Jasmine, define, project, or project? Township and range. Oh, no, sorry. All right, Rin, you're up. Project or define, project? On township and range? Because you're killing me.
I think we can define projected.
It worked? Let's see, actually, you might be right, and I'm just assuming because it's in the right place. Oh, you're right. Okay, then it was the project. I'm sorry. I'm getting mixed up here.
I know, it's just how I know.
I'm so sorry. No, it's not you. I answered everybody else's question. It's totally off the hook. Okay. So the DEM and the topographic map are the two rashes. I know we didn't do those. The topographic map.
It's hard to know, so we want to.
Actually, I think the topographic map, if I recall correctly, is undefined as the operator.
Oh, no, spatial reference.
It is undefined. Good call. So it is defined projection. So remember, we can't do that through here. We have to go through catalog to do the raster. That was the topographic map. We need to go to the property view. And edit it. We've got the spatial reference here. So this is a little bit different from the shape files, but you can find the spatial reference. It says undefined, and we need to edit it and sign it. UTM zone 13 north. And remember, if you're doing it through catalog, you got to hit refresh. All right, DEM. This is the refresh button right here down at the bottom. It's the two little circular arrows. All right, Tyler. DEM, project or define project? Yes, thank you. Good. We're getting there. We have the project under raster. Project raster. This one might take a minute because the rasters are such big files. I don't know how fast these computers are. Okay, I realize the colors are going to be a little bit different, but your map should look something like this. Your best clue that what you've done is correct here is when you get this little world logo, all your files show up in the same place. You're not looking at files way off in different spaces. If that's happening to you, you got something wrong. We ought to figure out which one it is. You guys think you follow this well enough to do it on a quiz? Would actually not be part of your grade for this quiz? What's that? I gave you that, you can figure it out. Okay. You're gonna have to do it on you. So you can have to download this. No, because you assigned a new coordinate system to it. So what you gotta do is go back to that. Yes. There's one more thing we have to do to finish this map. What is it? There's one more thing we didn't put in the correct view.
Yeah, so whatever you need.
Okay.
Yeah, so I don't know why it's not being made in that version. Putting it in. Yeah. Sorry.
No, because we're. You guys get
I've got one that's just a few shape files for you guys. All right, before we leave this map, one more thing we have to do. Rin said it, but I don't know if anybody heard it. One more thing that we did not do to finish this map and make it look correct. This is this is on your homework assignment. What did we miss? It's not in the correct coordinate system. The layers, the data frame. Check and see what coordinate system the data frame is in. Data frame is in WGS 1984. So even though all of our files are now in UTM, we're still viewing it in WGS 84. We're still viewing it as unprojected. So we put that in UTM 13 North. And now it looks correct. Stop stretching it out.
I was wondering why mine was different from yours, even though I had all these things.
This is always one of the most important steps. GIS is doing that on the fly projection, because remember, no matter what, these are all listed in whatever coordinate systems they're listed in. This is how we're seeing. So your coordinate system that you're viewing it in should always be your type priority. Everything else, if you're doing any kind of accurate measurement, make sure you go through this define, project, and project to get everything in the correct coordinate system that matches your data frame. Right? I bet that's what's happening with my work. It is. Yeah. You're running through all of them with the files, but still viewing it in a geographic coordinate system. Okay, so let's open. I'm going to do this one more time very briefly with the other one I put on the drive, the practice folder. There's a practice MXD map. I think most of you are getting this pretty well. Sounds like we had a couple of crashes and whatnot. But. So in this case, I gave you boundary correct and identified that one as the one that's correct. That's the time folder it's in.
Since I know it's one is in the correct data frame, why not just import the one that is in the correct data frame first always, so that then you don't have to go on the
That is a brilliant way to build your own map, but it doesn't work very well when I'm trying to teach you to pay attention to the data frame. That's the only reason. And I literally did that on purpose to make you realize that we had to pay attention to that. But otherwise, that is a great way to start your map. If you don't do that, if the first file you bring in, you don't know what coordinate system it is, always check what coordinate system your data frame ends up in. That was a really good question. See if I have one more in here. So we shouldn't save that last one. You don't need to save that unless you want to practice this, in which case I would say download it again, because you probably just saved all of those files under projected or whatever it was. All right. So we're in Gallatin County. This is the Gallatin Valley. We know that the boundary, this is the boundary of the Gallatin Valley. We know that the boundary is correct. What's your first step? We're in state plane meters for Montana. So that is the very first thing we want to do. Now from those there on, we check and see if all of these, and especially this one, are in state plane meters. The coordinate system for the entire data frame should automatically be put in state plane meters. If it's not already, well, I guess that one's actually in feet. So put it in state plane meters instead of feet. Major streams, define or project. It's in World Robinson and it's not showing up on the map. So we need to define it. It's four corners, define or project.
The four corners from the neighborhood is the same thing. Like,
Major road wasn't supposed to be on there. I brought in four corners from the other file. So just drag that one in that. Remove major roads, I'm sorry, I goofed those up. Was trying to build this at the last minute for you guys, because I wasn't sure if the person would be enough. The four corners is showing up on the map, but what we do, define or project it. Because why? It's undefined, exactly. So define the coordinate system on four corners. What about the logic framework? Done.
Yeah.
Exactly. Because it's where it's supposed to be, and it has a coordinate system already. It's in international state plane feet, and we want it in meters. All right. Now, if you're not sure, here's the best way to check. I tell you what the coordinate system of the correct file is in. Your data frame and every other file in here should be in the same coordinate system. And if it's not showing up where it's supposed to on the map, the one that's not showing up on the map was done wrong. Does that make sense? I'm not going to try and fool you. I'm not going to give you something tricky because this is a really difficult concept. To define project versus project is really hard, but it really underpins all of your data and understanding how to bring your data into the map correctly and how to view it correctly. Okay, I'm going to download from last class the Continental file, Continental US file. It was not the dissolve, but the entire US, United States. I'm going to download this one because you can look at this one to do the dissolve. I wanted to show you last class. And we can also use, I'm just going to start a new blank now. I'll show you another tool that a lot of people have gotten a lot of questions about this tool. Just emailed to me. So I'm going to bring back in from the projections assignment homework. I'm going to bring back in watersheds. And I'm going to bring back in the boundary. Richland County. just because I've gotten a lot of questions. 3 or 4 of you have emailed me about the homework assignment and saying that the roads extended out past the county. And how do you stop the roads from extending out past the county lines? In this case, watersheds extend out past the county line, but just like the roads on your homework, this is simply a larger file than the boundary. There's a tool for this that I have not introduced, and I will introduce soon. Well, I'm going to introduce it now, really. I had planned on introducing it soon, but because it kept coming up, I'm going to show you this tool. So it's a tool called Clip. What we want to do is, if we're focused on Richland County, we want to get rid of all the extraneous data that doesn't help us and doesn't tell us anything about Richland County. It just distracts from it, like we don't work that road that runs off the map. Go into Analysis Tools, under Extract, this tool, Clip. What I want to do, my input features is the feature that I want to clip. And clip, like, think of it like a pair of scissors, we're going to clip it. I want to clip the watersheds to Richland County. So what I want to do, so I'm having trouble getting this on the screen where you guys can see it. I want to clip the watersheds to the boundary of Richland County. Now all you have to do is tell it where you want it to go and give it a name. We're not going to do anything with the XY tolerance. What this is doing is saying, how far beyond this boundary do you want to go? If you leave that blank, it's going to assume you are dead on that boundary. If you give it a wide tolerance, it's going to flip around that boundary. So just say yes. Let's flip to my shapefile. We can do this with rasters too, but processing rasters is a little more intense. I'm going to keep watersheds in here, and I'm going to show you the opposite tool. I can remember where it is. Here it is. Okay. The opposite of clip is erase. Say maybe what I'm interested in doing is keeping the watershed boundaries outside of Richland County. We're talking about something outside of Richland County, but we've got to focus on a different data set inside Richland County. This erase tool effectively does the same thing. The input features are the same, watersheds. The erase feature is Richland County. What we want to do this time is erase inside the boundary. Again, just give the location and a name. And we don't need to fool with the tolerance because we want it to flip directly to that line. Now, we've cut out everything inside. Flip and erase are opposite ends of the. But if you're looking at a shapefile and you want to get rid of everything inside or outside of that, you have those two tools to do that. Comfortable with that one? Okay. So let's go create a new one. And we'll go back and do what we did last class. All right, bring up your United States. Let's bring that into your map. And I'm going to show you the dissolve tool. So this is how we saw the United States before we flipped it down to just the continental United States. So I'm just going to zoom in on that. This is showing every county boundary inside the United States. I went online and I actually specifically looked for a state map, and I couldn't find one that was just the states. This is what I found. It gave me these extraneous lines that I'm not interested in. But I can take this data and very easily turn it into a state map in just a couple of seconds. Right click and look at the data in the attribute table. There's a couple of things in here that we can dissolve by. Remember, this started as the entire world map. So it has a column for the different countries. We separated out the United States. Now they've got name 1 is the name of the state itself. We've got type is a state. We've got all kinds of information in here, but if you look at it, the name 2 is the name of the different counties. So it's actually separated these out, and what we're interested in is getting rid of everything that's county and just going down to Texas, Minnesota, Michigan, whatnot. We want to get rid of the counties and just keep the state lines. So what we want to do is dissolve inside the state lines. In order to do that, we need to figure out from the attribute table what we want to dissolve by. Main one will work. But let's try this first. Half the fun is figuring out where all of your tools are. The tool I want is dissolve. What I want to do is in this one file is the file I want to dissolve, United States. Give your name and the location you want. And we'll come back to this, but right now we're just going to leave this alone, not check anything, and say, okay, run that dissolve tool. And you can see it's showing us that it's processing down at the bottom. When you have decent computers, this would happen in about half a second. This is not a difficult tool to process. It got rid of all of the lines inside the United States. Not really what I was looking for. I was looking for dissolving it by state. So I'm going to run that dissolve tool again. Again, starting with the first one, but this time, I'm going to check main one, because that is the column that lists the different states. So say, okay, I'll run that one again. Main one we specified was the name of each state. This one resolved it into states. Now, if we had extra information in here, in the attribute table, you could dissolve by whatever you wanted to. You could dissolve by whatever information happens to be in the attribute table. So this tool, we're only using this because you have a couple of different options in here. But this is your dissolve tool. So you guys now have several different tools in our toolbox. This is where the real powerhouse for ArcGIS comes from, Arc Toolbox. You can do all of this viewing and manipulating the symbology and looking at all this in Google Earth and other GIS software, but the powerhouse of this particular software is this Arc Toolbox. Whatever you want to do, you can figure out how to do it through Arc Toolbox. There are a couple of really terrific extensions that the university has given us permission to use, but if you're doing them at home, you might want to, well, you're going to have to turn them on if you're doing them at home from the license that I gave you, but chances are you're not going to find them in the future. A lot of people don't want to pay for the extensions, but this is really where I want your final project to come from, is actually doing some analysis, not just looking at files or doing, what I want you to do is kind of process through some data. And as the semester goes on, we'll look at more and more tools and we'll actually start doing analyses. But I'm going to drop it in your mind right now. This is where I want you to start thinking about your final projects and come up with something that you think you can do a cartographic analysis on. Start thinking about it. So I don't have anything else for you tonight. We kind of rush through that, but I don't want everybody to get stuck in the snow either. So I'm hoping we will wrap up early, but we're not wrapping up very early. Is everybody comfortable with the find, project, and project? Okay. Treat your data frame or your layers as if it was another one in there. Okay, well, that's all I have for you tonight. So thank you for your time, and please be careful driving home. It's just not getting dark, so hopefully the roads haven't frozen yet. All right, thanks, Chris.